Now would be a great time to introduce you to the use of timers. As per the writing on this slide, you can see that there are going to be on delay as well as off delay timers that we can encounter. I have taken the liberty of designing both circuits at the same time. The top two lines of code are going to refer to an on delay timer, and there you can see I've got on delay timer number 0. And the bottom two lines are going to refer to an off delay timer, and there I've got T off 0. Those are the two timers that I'm going to use. Now let's just deal with them individually and then do the simulation. The very first of the two that I'm going to do is going to be the on delay. Now what's going to happen is when I give it a trigger, it's going to delay for a certain period of time, and only then is the output going to switch on. And when I take the output or the trigger, when I take the trigger away, the output will switch off immediately. So as soon as it's given a trigger, what will happen is that it will delay and then it will switch on. And when the trigger switches off, the output is going to switch off. That is exactly what we are going to demonstrate right now. So there is the circuit in front of you. I'm going to go to switch A, which is my trigger for the T on. And this timer, by the way, has been set up for 5 seconds. So when I give it the trigger, you can see that the timer is going to start to time out, and after 5 seconds the output light will switch on. If you have a look at this T on output Q, that is what most PLC manufacturers use to indicate that the timer has gone and timed out. If I take the trigger away, the output switches off, and then when I switch the trigger on, it's going to delay by 5 seconds before it will switch on. So here goes again. I'm going to switch it on now, and it's going to delay by 5 seconds, and then it's going to switch the output on. So this is known as an on delay timer. Let's go and have a look at the off delay timer. Now this one is going to be slightly different, and that is when I give it a trigger, the output is going to switch on immediately. But when I take the trigger away, this is where the output will delay switching off. It will stay on for a period of time, and then it's going to switch off. Again, if I was to give it a trigger, the output will switch on, and as soon as I take that trigger away, this is where the delay kicks in, and only then is it going to switch off. So we call it an off delay timer because it delays switching off. We are now going to have a look at the bottom two lines of code. So you'll see that when I give it a trigger, the output is going to switch on immediately. And when I take the trigger away, the output is going to, in this case, also be delayed by a period of 5 seconds before it switches off. So here goes, taking it away now, and you can see that it stays on for a period of 5 seconds before it goes and switches off. So this is known as an off delay timer. Again, I'm going to give it a trigger. It will switch on immediately. When I take the trigger away, it's going to take 5 seconds before it switches off. It delays switching off. The top one is an on delay. When I give it the signal, it's going to delay by 5 seconds before it goes to switch on the output light itself. So pretty straightforward. You will use these in a host of different applications. And that concludes my on delay as well as off delay timers. Many different applications where you can go and use these.